Good morning, everybody. Welcome back to lecture number 37. So today we will, last time we talked about short transmission line. What is the length of short transmission line?
Under 80 kilo.
Under 80 kilo. So, short is under 80 kilo. Medium is 80. This is length to 250. And long is greater than 250. Maybe you put equal, I don't care. Doesn't matter. What was the feature of short transmission lines? We have a sending end, we have a resistor, and we have a receiving end. R, and I told you put the J. We have the same issue as the induction motor. The slides do not put the J. The slides do not put the J on the circuit, but they put it in the calculations. The slides do not put the J in the circuit, but they put it where? The calculation. But for you, you're experts. The only place where you don't need the J is the DC motors. In the inductance over there. So what is Z? This is VR. You agree with me? It's a load or something. And I told you to look at it as a two-port network where you will have 4 terminals, 2 terminals, but 4 entries. You have IS, you have IR, you have VS, you have VR. So your goal in the ABCD to get VS and IS as a function of IR and VR only. Why? To see if you change the load, you're going to change. How would that change the VR? How would that change the drawn current on your sending end? So imagine with me if you have a sending, receiving, sending, receiving, sending, receiving. If you know the effect of this box and this box and this box, you can predict the behavior of the grid. صح ولا لا? Where every box is 2 lines with sending and receiving. In 360, we only look at 2-bus system. 1, 2. In EE 460, 463, those codes in level 4, you're going to see 3, 4, 7, and you have a systematic way of doing things. That's why we put everything here as a matrix, A, B, C, D. In the software, you have to put them in the matrix. Clear? So, in the short transmission line, what was the relationship? VS would equal to VR plus I times Z, where Z is R plus JX. Don't forget the J, please. So what was the A? The A was 1, the B is Z, the C is 0, the D is R. A, B, C, D. Memorize or derive. I would say derive is better. Maybe I will not give you this in the test, because it's circuit analysis. But why we give it here? To make analysis easier for computer implementation. Okay? So in the project you can include this in your project. That's a very good question. Okay? So what was also the other feature? Voltage regulation is just VS minus VR over VR because A is 1. VS minus VR over VR. In medium transmission lines, we have capacitors in parallel. Cannot ignore them. You cannot ignore them. So capacitance of medium lines is significant, as well as large is even worse, and cannot be ignored. So there is 2 possible representations. Both of you would give you the same outcome. Maybe this is different than that one. Maybe there is a marginal error here. There is a pi model. There is a t model. The t model looks like this. The pi model looks like that. Be careful when you play with these models. Why? Because every quantity here is defined explicitly. Here it's c over 2, c over 2. Here it's c. So one major is this one. We have two parallel capacitors with c over 2, c over 2. Here we have in the center capacitor of c. Here we keep the impedance, which is z of the line, the same. Here we split it into two halves. Z over 2, Z over 2. So either of these models, you have to split something in halves. The pi model would split the capacitors in half. The T model would split the line into half. Which one do you think is better? Well, I see this is more practical, easier. Because if you make a mistake in the C over 2, it will be more ignored. But if you make a mistake here, you're impacting the line itself. And remember, for short, we ignore the line. Now, I want to give you a simple notation. In the last exercise, which is made for practice, he's telling you a transmission line of 140 kilometers, but he's writing a note. The voltage at the receiving end of the transmission line is 210 kilovolt. Although this line is B medium, they will treat it here as short to simplify analysis, and at this voltage level, maybe the differences are not that much. The higher the voltage, the higher the capacitance. Why? I will show you later why. But if you look at the medium, you would notice that there is a quantity called ICS, where ICS is proportional to the voltage at the receiving end. So if it's high, that current is high. If it's low, that current is low. So not only length of the line would tell you which model to use, it even tells you the higher the voltage, the more of this current will flow through the capacitor. You see it? We will go to the details now. But keep in mind, the last exercise, he's simplifying it. But it's medium. It's 180 here. So, in the pi model, I told you half of the capacitance is presented. In the T, all of it here, but the line is split into half. Okay? The series impedance is divided. Let's do the math. Please focus with me, because I might ask you in the test to derive the A, the B, the C, and the D. Not only memorize. Maybe I will not give you hints. I'm gonna draw the circuit. So what is happening here? What is happening is you include two capacitors in parallel. C over 2, C over 2. You agree with me?
Yes.
So, you start first. What is the Z? R plus JX, or R plus J omega L. You agree with me? Okay. Here, let's define a quantity Y to be 1 over Z of the capacitor. What is the impedance of capacitor in general? Here is the trick. It's 1 over J omega C. صح ولا لا? So what is Y? Oh, no. 1 over J omega C. So what is Y? J omega C. What is Y over 2? It is 1 over ZC over 2. Which is what? 1 over 2J omega C over 2. Which is what? في خطأ؟
اتوقع انه يكون مفروض على الطلاب. مو اوفر لا هي صح بس المفروض التو فوق.
You're right, it's here.
لا فوق أبد.
It's the same. C over 2, it's the same.
Okay.
It's the same. This is not a mistake. C over 2 or 2 here, doesn't matter. So this will be what? J omega C over 2. You agree with me? So if you change the capacitance in half, your admittance will change in half. So what's the unit of Y? Mho. Or this way, or Siemens. 3 units. Admittance, سماحية. What's the unit of Z? Ohm. Agree with me? So now let's label the current. What is this? What is this current? IS. What is this current? IR. What is this current? We call it I. What is this current? I, capacitor send. What is this current? I, capacitor receive. You agree with me?
Yes.
So, let's start from right to left. Start from where? Right to left. What is I? This current I is IR plus ICR. Remember, my goal is to write everything as a function of IR or VR only. So what is IR? Keep it. What is ICR? The Ohm's law is V equal IZ. صح?
Yes.
Or I can say I equal V over Z or Y of Z. You remember this?
Yes.
So can I say ICR is Y over 2 times VR? Yes. So I wrote everything as function of IR and VR. Okay. Let's do KVL around this loop. You will have voltage rise or voltage drop. Vs minus I Z minus VR. Can I do my trick? Yes. Vs is IZ plus VR. VR plus IZ equal Vs. KVL. I'm not going to teach you KVL again, please. Clear? What is IZ? This is the I. IR plus Y over 2 VR times Z plus VR. By grouping,
هي غلط دكتور. القوسين اللي داخل المفروض تشيلهم. صحيح؟ لأن الفي ار مضروب على الواي اوفر 2 بس.
صحيح.
Yeah, right.
correct now, right? That is how I is IR plus Y over 2 VR times the Z. So what is the VR? 1 plus Y over 2. And then there is a Z. Okay? Plus
ZIR. ZIR.
So in the short transmission line, what is the capacitance? 0. So what is Y? 1 over J omega 0. So this will be blown away and it will be VR plus ZIR. In the medium you have ZY. So this is the first equation. Now, what's the second equation? I finished VS as function of VR and IR. This is not I times R, this is IR. You agree with me?
Yes.
Here, now let's get the ICS. What is ICS? ICS is VS times Y over 2. You agree with me? نفس هذه. ICR is Y over 2 VR. but here I'm descending it, which is equal to, what is Vs? 1 plus Zy over 2 Vr plus Zir times y over 2. So what is Is? Is I plus ICS. So now ICS is function of VR and IR only. Okay? You want to multiply by y over 2? Let's do it. No, let's keep it. So Is is I plus ICS. What is I? It's this quantity. IR plus y over 2 VR plus y over 2 1 plus zy over 2 VR plus zy over 2 IR. By grouping, let's do an IR first. What are the coefficients of IR? 1 plus zy over 2. What are the coefficients of VR? Y over 2 plus y over 2 plus zy square over 4 VR, which is equal to y plus zy square over 4 VR plus 1 plus zy over 2 IR. Take the y as a common factor. 1 plus zy over 4 VR plus 1 plus zy over 2 IR, and this is the C, this is the D, this is the A, and this is the B. Clear how to derive it? So, the A and the D are 1 plus zy over 2, the B is Z, the Y is Y plus times 1 plus zy over 4. I might ask you in the exam, derive it. And if you don't show me these steps, it means you're memorizing. So do you understand how to do it? Again, the step is write I as function of IR and ICR. ICR is VRY over 2. Go here. What is VS? VR plus IZ. You got VS as function of IR and VR. Then you do an IS, which is ICS plus I. An I is already found by this formula, IR plus Y over 2 VR. You multiply it with you add it with ICS, but you already defined what is VS as function of VR and IR, and then you can calculate those 4 parameters. This is very important. All the simulation softwares, they have A, B, C, and D. Clear?
دكتور في الاكزام لو انت ما خلتني اسوي الدرايف المفروض اني اسوي له ممرايز يعني عشان الشورت تايم.
You can memorize to verify the answer. Give me 1 second. So, any question about the pi model? So what was your question?
أنا
Memorize it to verify you get the right answer, okay?
يعني both.
Both. Okay? Why I want you to memorize the procedure or practice it? Because this is used everywhere. This is the fundamental theorem of. As a matter of fact, there is many softwares they use pi model. There are some softwares they use the T-line model, and they're basing their code on these analyses. There is a question, conceptual question, is why we write the capacitors as Y? Why not Z? It has historic reasons, but also computer science reasons. If you do 1 over Z in your calculations, basically you write I as function of V over Z. This is not practical for old computers because division is more expensive in computing power than multiplication. So that's why they use the admittance to multiply things. In the 80s, 70s, even early 90s, division for big systems is very expensive. Until today, it is better to multiply than divide. You don't believe me? See how your calculator, if you do 1 over 5 plus 5j, it takes more time than if you multiply. And you all see how struggling you get with dividing by complex numbers. Clear? So why we use admittance? Because it's easier for software computing. Please keep that in mind, okay? The T-line model. What is the difference? The difference here is not much. We have the same x, we also have the same y. So y in the T-line, the T model, same as the pi. Here this y in the pi model is y, but here we divide it by 2. So the C is the same. The capacitance of the whole line is the same. It's a matter of you divide them at the beginning and the end, or you put it in the middle. Don't confuse yourself. Stick with the equations. If you do this, I'm not going to draw it on board, because most likely, most systems, I would say, if they don't ask you which model to use pi model. But you also have to use T to know T model. As a matter of fact, there is one software that I dealt with. They have a routine or sub-software. They call it add-on. This add-on, they named it T-line. T-line. From T model. They call it T-line because it uses T-line model. So what is X? This is X, which is here X over 2, X over 2 is omega L. What is Y? J omega C. What is VC? VC is VR plus IR Z over 2. Where? What is IC? IC is VC times Y. This is the VC, VR plus Z over 2 IR times Y. So this equals to Y VR plus ZY over 2 IR. So what is IS? He's calculating IS before VS. Is IR plus IC. IR plus IC, which is IR plus YVR plus ZY over 2 IR. So IS would equal to YVR plus 1 from this one plus ZY over 2. So this is the C and this is the D, not the A and B, because we started with IS. Here we have a mistake. They did a mistake. And I will let you figure it out now. VS, what is VS? Is VC plus IS times Z over 2. You agree with me?
Yes.
Let me change that color. Use purple. So VC is what? VR plus Z over 2 IR. This is VC. Plus Z over 2, this is the Z over 2, times IS. Where is the IS? The IS is this equation. No, it's this equation. اللي بالأحمر. Put it here. What do you notice? take البارامترز حقت VR 1 plus Z over 2 times Y 1 plus Z over 2 times Y correct. Take IR Z over 2 plus Z over 2 IR, that's Z, so Z times 1 is Z, that's correct, plus Z over 2 times Z Y over 2. What is that? Z squared times Y over 2 times 2.
Oh, yes.
So what is the mistake?
The two. Combined.
So this 2 should be
4.
4. Okay? In this slide, this 2 should be 4. However, the author of this slide, he put the 4 here already. So this is correct. This is correct. So the B here should have a 4. Fix it. Okay? Maybe I will forget to fix it. Maybe. Do you all agree with me that should be 4?
Yes.
So why you're not putting it in your notes? Because you're gonna watch the video, huh?
Yes.
Good job. Okay? Please, did you notice this typo? This 2 should be 4, and this 2 should be 4, and everything should work fine. What if I ask you to derive the T-model test? Can you do it?
Yes.
I might ask you to derive both of them. Maybe solve the example with both models. Because transmission lines are so valuable to me, okay? Any question? So remember, the two-port network, you write VS and IS as function of IR and VR. What are the consequences? In the short line model, we had Z to be 0, right? So if there is no capacitor for voltage regulation at no load, the current here will be 0. If no capacitors are here. You agree with me? If no capacitor, this is VS, this is VR, this is maybe the sending end, usually a source. At no load, this open circuit, so I is 0, صح?
Yeah.
So VR equal to VS because the A is 1. معين. The A in the short line equal to 1. No, not VR. For the medium line, if there is no load here, still there will be current flowing through this capacitor and through this line and this capacitor. Even though IR is 0 at no load, there is still current flowing in the capacitors. That's the difference between medium and short. Those parallel capacitors would take 9 at no load. So, to fix this equation, you have to get this output is Vs over A. Why it's Vs over A? Because go here, if you make IR 0, Vs at no load, or VR at no load is Vs over A. If IR is 0. So for medium line at no load, this IR is 0. But this I is not 0. And this is a more accurate model. Because it makes sense. You should have, at high voltages, you should have parallel capacitors. And if you note that these parallel capacitors, the current through them, in either model, IS is proportional to the receiving end voltage. So if this voltage is high, this current will be high. Even though for the T-line model, the IC, if VC is high or Y is high, IC is high. This is how you should read the equations. Clear, Omar?
Yes.
You have to watch the YouTube video. Okay? So at no load, the voltage regulation is Vs over A minus VR over VR. The efficiency is the same. You get the P sending efficiency, P receiving end efficiency, as well as the actual efficiency, which is PR over PS times 100. Okay? Before we jump to this example, which we will not finish today, what will happen on Tuesday?
ثلاثة والإطلاق والخميس.
فيك الكوز الخميس.
13 سنة.
Online lecture. I'll take attendance online, okay? Okay?
ما حيكون في حضوري.
No, I'll be out of. I'll be traveling, okay?
نفس الوقت يا دكتور ولا
نفس الوقت. واحد تبغانا في الليل؟ Just keep the time the same.
فيك كويس حيكون خميس.
خميس in person. I'll never cancel lectures. Because we're متأخرين في المنهج.
دكتور متى لك كويس؟
This chapter. Transmission line until what we finish on Tuesday. Most likely I'll ask you either this example or the first example. Maybe this example, because I love this example. But I will not give you the formulas. Maybe I'll ask you to derive the formulas. I don't know. So how many lectures you have to watch for a fake quiz? Only 3 lectures. Last lecture, which is uploaded yesterday, today's lecture, and tomorrow's lecture. Just watch the lectures, you should be fine in the fake quiz.
خطوات التي موديل
You have to know. To me, this is more important than the machines. Yes. You have to study this very hard, okay? So I'm not gonna solve it, but I will show you today. What time is it? We have 9 minutes. So 60 hertz, 3-phase, 200 kilo. This medium, right?
Yes.
Delivers 400 megawatt of power of load to the load of 380, a power factor of 8 lagging. This statement describes the VR, IR, PR. So load is 400 megawatt, 0.8 lagging, with VR to be 380. So we love line to line. So what is VR if we draw it in the single phase circuit? 380 over square root of 2. So that's the first step. The first step to solve this equation is to draw the single phase equivalent circuit of the pi model. So here what is the P? R 400 megawatt at 0.8 PF lagging, okay? What is a VR? We love line to line. So what is VR?
AFT divided by square root of 3.
You understand why? Because in the communication language is line to line. But what we are drawing is single phase equivalent. Is this a single phase or 3-phase circuit?
Single phase.
And it's Y to Y connection. The quantities given here is a 380. It means if I measure phase A and phase B, it should be 380. Why? Because the line man cannot measure one line and ground. He only measures the voltage between the 2 lines. It is safer. Because if you measure the line-to-line voltage, there is equipment. You just connect it and you measure the line-to-line voltage. But if he just put the equipment to one line and to the ground, he closes the circuit. The language of communication, line to line. So what's the language here? What should you solve for?
Hey, single phase.
Now, if he tells you delta connected, you know it's B line to line equal to phase. please, okay? 380
ما
kilo divided by square root of 3 and take it as a reference, okay?
ما منشان تسجلته ولا هو.
If he doesn't tell you,
So
y is more dominant in the system. Wow, clear? So what is an IR? P over 3 VR cosine theta, which is 400 megawatt divided by 3 times 380 over square root of 3 kilo times the 0.8. What should be the answer?
Angle minus 36.9.
That is correct. So 7, I'd say 759.7. Then it is amp at an angle of
Minus 36.
minus 36.87. Why? Because theta is plus 36.87. Theta I is 0 minus 36.87. Actually, this is theta R, this is theta IR, to be specific. We're experts. What is a Z? Z is 200 kilo meter. Should you multiply 200,000? No, because the R, will L, will C is in per kilometer. So kilometer will cancel kilometer. So 200, don't multiply 200,000. Very common mistake. R plus J omega L. It's 200 kilometer. This is, I'm not going to write kilometer, just 200. What is the R? 0.035 plus J omega 2 pi 60 times the L, 0.9 milli. Just do it by calculator. 200 times 0.035 plus J times 2 pi times 60 times 0.9 milli. You should get 7 plus J times 67.9 ohm. So this is your Z. The last thing is, what is your Y? J omega C, which is J times 2 pi 60 times the C. What is the C? 0.015 times 10 to minus 6. Of course, you have to multiply it by 200. So this is the impedance per unit of length. If you multiply it by 200, this is the impedance. Okay? So J times 2 pi 60 times 0.015 micro times 200, which is J times 1.13 times 10 to minus 3 ohm. No, mu or Siemens. Okay? This is admittance, this is impedance. From that, the next step is to, we'll start at next lecture. We have to get the A, the B, the C, and the D. So we just solved up to here. No, maybe up to here. We got the same numbers. So next lecture, we have to calculate what is the A, B, C, D. Maybe one of them is easy. One of B is Z, so 7 plus J. What is A? 1 plus Z, Y over 2. What is C? Y times 1 plus Z, Y over 4. What is D? He is A. Clear? Any other question? So the next lecture, what we'll cover is we'll solve this example. We'll talk about conductors. We'll talk about insulators. We'll see the corona effect. And we will have some practical example. And then we'll finish this model. Clear? So the final exam, the first problem, maybe one of the big problems, is the transmission line problem. For sure. Think of me as a person who writes the exam. So there is a guaranteed information from this. Does it make sense? It makes sense. And it be vicious, to be vicious, maybe very long problem. What's an idea in my mind is I will ask you to solve for pi model and t model and compare both answers. Can you do this? I don't care. So try to solve this example that we saw today using what? T model. And see if the answers are the same or different. Similar to the question the major, I'll get back to you. Do you remember the induction machine problem? What was it? At slip equal max. Did we use the formula had torque max? So I asked you to derive it. And what was the efficiency? Wrong. What was the efficiency of the induction? Wrong. It was 60 point something.
95 غلط.
غلط.
في شيء 95.
Exam was half.
Fine, comprehensive.
Yes. No.
في مجال نخلي كومبرهنسيف أسئلة الكونسبت والرتن يكون على الموديل الأخيرة.
Model ahead is very easy. It's better to have it comprehensive. If I make the material is too small, I'll bring tough questions. Trust me. The goal is to make sure that you know the course by heart. In 10 years, I want you to remember this course. Still have the project to do.
Next up,
Can leave if you want.
for electrical machine course next semester.
462.
Yes. ما قدرت ألحق، هل في مجال فتح
I don't know. Talk to the undergraduate.
البيتيشن يعني؟
It's closed now. I think there is only one guy. That.
أحمد لحق.
Yeah, I saw his name. But most of them are seniors already. For a second section. Petition for a second section. Huh?
Of course, يعني كويس. بعدين دكتور
I don't know. We'll see. So if you have issues with the registration, go to the undergraduate office, okay? Not your advisor.